You know how in programming, you usually have to pick one? You can have blazing speed, like you get with C++, or you can have rock-solid safety, which usually means sacrificing some of that speed. It feels like you can't have both, right? Well, today, we're going to pull back the curtain on Rust and find out how it breaks that rule.
Okay, this quote right here is the whole puzzle. Most languages that are safe use something called a garbage collector. Just think of it like a little janitor that has to periodically pause your entire program to go find and clean up old data. It keeps things tidy, sure, but those pauses, they can kill your performance. Rust says, no thanks, I've got a better way.
So, that is the big question, isn't it? How on earth does Rust pull off this magic trick? Well, it all comes down to one core idea, something you won't find anywhere else. It's a concept called ownership, and by the time we're done here, you're going to get it completely. But before we reveal that big secret, we got to start at the beginning. Because Rust's whole philosophy of safety and doing things right, it starts the second you even think about creating a project.
So let me introduce you to Cargo. Seriously, this thing is your new best friend. In a lot of other languages, you're stuck grabbing different tools for building your code, managing libraries, running tests. It's a whole thing. Rust just gives you Cargo. It does everything. One command to start, one command to run. It just gets out of your way so you can code.
In this right here, this is a piece of Rust's DNA, safety first. In most languages, when you create a variable, you can change it whenever you want. Rust flips that completely. By default, everything is locked down, what it calls immutable. You can't change it. If you want the ability to change it, you have to ask for permission by adding that little mute keyword. It's a simple change, but it prevents an entire category of bugs right off the bat.
All right, basics covered. You ready? It's time for the main event. Let's get to the heart of it all, the one thing that lets Rust deliver on that impossible promise of speed and safety.
And here it is, ownership. It's not a program that runs in the background. It's just a set of rules, and the Rust compiler knows these rules by heart. So instead of cleaning up messes later, it just prevents them from ever being made in the first place. It's all about being proactive. The whole entire system is built on these three rules. That's it. 1, every piece of data has one and only one owner. 2, you can't have two owners at the same time, no sharing. And 3, the second that owner is finished, the data it owns is immediately deleted. Poof, gone. Now these sound simple, I know, but trust me, their consequences are profound.
Let's see rule number 2 in action. We create a string. S1 owns it. Then we say S2 equals S1. Now, in many languages, this would just make a copy. Not in Rust. In Rust, ownership is moved. It's like you literally handed a physical object to someone else. You don't have it anymore. Now S2 is the one and only owner.
And this is where it all clicks. If you try to use S1 after you've given it away, you get an error. But here's the absolute game changer. This is not a runtime crash. This is a compile time error. The compiler, your helpful partner, physically stops you from writing buggy code before it even has a chance to run. Okay, so you're probably thinking, well, what if I just want a function to look at my data without giving it away forever? Great question. And that's where borrowing comes in. See that little ampersand symbol? That's the signal. It says, hey, you can look at this, but you don't own it. The function can use the data, do its thing, and then S1 is still there, happy and usable. It's so elegant.
So we've seen how ownership keeps us safe, but it's not just about preventing bad things from happening. This solid foundation actually enables some incredibly powerful and clear ways to structure your programs. Let's see what it builds.
Forget your old switch statements. In Rust, you have match. And yeah, you can see it's like a switch on steroids. It can handle single values, ranges, all sorts of complex patterns. But here's its real superpower. The compiler will not let you finish unless you have handled every single possible thing that could happen. That little underscore at the bottom, that's our catch-all. You are guaranteed to never have a bug because you forgot to handle a case. It's just not possible.
When it's time to organize your data, Rust gives you two main tools. First, you've got structs. Think of these for when you want to bundle a bunch of related properties together into one thing, like a player having a name and health. Then you have enums. You use these when a value can be one of a few specific things. A web event can be a page load or a key press, but it can never be anything else. This makes your code super explicit about what's possible. Now, this idea of being explicit and robust leads us to one of the biggest headaches in all of programming: errors. Rust just throws out the old ideas of nulls and random exceptions and gives us something way more predictable.
In Rust, when you do something that might fail, like reading a file, it doesn't just return a file, or nothing. It returns a result. And a result is always one of two things. It's either OK with the successful value tucked inside, or it's error with the error information inside. There is no maybe, there's no null. It's one or the other.
And how do you deal with the result? Well, with our good friend match, of course. And this is where it all comes together so beautifully. The compiler forces you. It literally will not compile your code unless you explicitly say what to do in the OK case and what to do in the error case. You can't forget to handle an error. The system makes it impossible. So let's bring it all home. Rust's big promise, that combination of speed and safety, it really isn't magic. It's just a smarter way to think, built on this secret sauce called ownership. It means your compiler becomes this strict but super helpful partner that catches your mistakes for you early. And then features like match and result just build on top of that, helping you write code that's incredibly robust by design. And all of this leaves us with one last big thought. We live in a world that is completely built on software. And maybe, just maybe, a language that demands this much rigor, that is this focused on correctness from the very start, maybe that's exactly what we need to build a digital world that's faster, safer, and a whole lot more reliable.